afternoon. My name is James. These are my group members, Dean, Kathleen, and Brian. We'd like to thank you all for being here today, and especially thank you to Goodyear for giving us the opportunity to work on this challenge. Also, thank you for the tours of the facilities. They were very enlightening. So for those of you that know, or as some of you may know, and for those of you who don't, the groundwater in Goodyear is not perfect. In order for this water to be drinkable, it must be treated by way of reverse osmosis. A byproduct of the reverse osmosis process is brine, lots of brine. The RO facility in Goodyear can produce as much as 500,000 gallons a day in brine water. Currently, that brine is being sent through a sewer to the water reclamation facility. Sending it there increases operating costs as well as increasing salt levels in the reclaimed water. With too high salt levels in the reclaimed water, it makes it difficult to discharge. So what are some sustainable or cost-effective solutions to this brine management challenge?
So right now, Goodyear's current efforts are on an education-based system, as well as some others that are listed above, with pamphlets and brochures such as this that are distributed through schools and organizations. We're going to pass this one around for you guys to take a look at. And like I said, right now, the brine is being mixed with the sewage water and then transported to the reclamation facility where it is reclaimed there and sent to the nuclear power plant for cooling of the reactors. And so besides the 2 times a year that APS comes in and does the inspections, and that being in April and October, and so we're going to go over some solutions to fix this problem of brine. We chose our solutions based on being as environmentally friendly, cost effective, and as well as maintaining citizen satisfaction, since 90% of your citizens says they live in excellent conditions, which is amazing. We want to keep that number as high as possible. It's difficult to do that with such a mushrooming population, having to take care of roads, schools, and other expensive sets. So what I'm going to be going over with you today are the evaporation ponds. Evaporation ponds are fairly simple. It's just a polyethylene lined pit where you will dispose of your water. It's usually very large in surface area, so it requires some digging and some money for the polyethylene to line it. What happens is the water sits there, gets evaporated in the air, the salt lays down on the ground on the bottom after it is evaporated, and you could either sell that salt to private companies or dispose of it or by any other means. That's why we think it could be a profit driver, possibly privatizing that whole sector and being able to have an organization come in who wants to use the brine. And it can also be used for pan data, which is developing probabilities of net evaporation. So that's very beneficial in the desert, since we could not use enough research on foreseeing the possible outcomes of dry climates in the future. So we looked at Oman and the United Arab Emirates. They use we studied 5 different RO facilities. They share a similar climate to us with a hot, dry, arid climate with similar weather conditions. It was very cost effective for them since they use the same method that is currently being employed between the RO facility and the reclamation facility, where it's all being transported to one, treated at one site, and then sent to the evaporation ponds. So this is a cost. You could see in the 5th column there, it is the cost of construction, and in the 6th column is the pond size. So you could get an idea of how much that would cost for how big of a site you want to establish. We noticed while we were at the site that you already have a sort of large pit that could be lined, possibly cutting out the cost of that. And it looks very similar to a site that's being developed in this picture. What you see on the bottom is a high salinity. That's the white on the bottom, and there's obviously some vegetation that needs to be cleared out. But we think this could be a great experimental site for evaporative ponds. And Kathleen will. And some of the only problems that we found really were that there were constant holes and leakage. The main benefit of having evaporative ponds is you don't have to. It's not contaminating groundwater, and when there's leaks in that, that's obviously a flawed system. So that would require inspections, which could cost drive up. But then if it's privatized, you don't even need to worry about that. That'll be on their accord. And Kathleen will talk to you about other solutions that we've come up with.
All right, so another alternative that came up in a lot of the research articles was the use of pipelines to transport the brine or wastewater from the site to a different location that isn't right there. One of the first ones that Ahmed et al. 2000 talks about is a deep well injection. And as you can see on the left-hand image, what that would kind of look like, injecting the brine through the different layers deep underground. It's one of the more frequently used methods in the US and otherwise. It has less technical difficulty. This could be because it's more of an established method that we're used to with other substances. And the image again, that's in Lake Meredith, Texas. However, downsides to this, the regulation can be very strict, and more importantly, the geologic site is extremely important, and most studies say that central Arizona isn't necessarily a great geologic site for this. It's more useful in places like Texas or Florida. So another implementation of the pipelines would be brine lines, as they call it, which goes from the site to an ocean or other body of water. An example is shown in construction in Southern California. It's actually funded by the EPA, so we found that from a report through them. Benefits, according to an article in 2011 by Paulson, he argues that it's one of the most environmentally friendly options. And although this can be true, some do argue against that because of the safety of marine ecosystems that you're putting the salty brine water into. Potential problems, again, come about with viability. So it might be useful in coastal cities, but not necessarily with Arizona or with Goodyear's position. Another one would be that it requires coordination and cooperation throughout all of the counties involved, which, as we've learned in this course, isn't as easy to come across as we would expect. So again, while these could be recommendations, they might not be high on our list simply because of viability, regardless of their potential environmental benefits. So now Brian will talk about algae instead.
All right, so I'm going to talk a little bit about algaculture, and algaculture is actually just the farming of species of algae. And the benefits of growing algae is that it can be used as a fertilizer, it can be used as a food source, and it can also be used as a fuel in biofuel. And a study done by Dr. Terry Baxter, he grew algae in test tubes. He used a 60-30-10 method, meaning 60% wastewater, 30% brine, and 10% algae. And he found that it reduced chlorine, phosphite, sodium, and magnesium that was already in the brine. And the picture on the right there is some of the algae that we found at the treatment facility, and we felt that the algae already there could be subsidized to either use as fertilizer, a food source, or as an energy source. And now, really the only downside I could think of to algae is that it's very labor intensive, requires a lot of maintenance to go out to keep it up. And now I'm going to pass it to James to talk about wetlands.
Thank you. Okay, wetlands. Through this approach, the brine would be treated through a series of wetlands designed to reduce contaminant levels. After the wetlands, the brine would then be mixed with effluent or other waters in mixing ponds to further reduce the total dissolved solids. From the mixing ponds, the blend would then be discharged to the Gila River. This strategy has many benefits to society and the environment. First, the strategy is relatively inexpensive and cost-effective compared to the other strategies. Second, a minimal amount of energy is expended managing the brine. Third, the strategy supplies water to the Gila River, which would help restore the wetland habitat. However, we have noticed varying results from the experiments and other case studies. In some cases, the brine is not remediated to environmental standards. So an additional technique that we researched and decided to propose is a mechanism that is commonly known as a permeable reactive barrier, or a PRB. A permeable reactive barrier is an engineered zone of reactive material placed in an aquifer that removes contaminants from the groundwater flowing through it. Contaminants are either immobilized or chemically transformed. PRBs have been in use since about 1970. Unfortunately, we were not able to find any case studies on strictly brine remediation through PRBs. They are typically used to remediate contaminated water from mine tailings, hazardous spill sites, or seepage from landfills. However, we researched several PRB case studies and examined the contaminants that were removed. Several of those contaminants are similar to the constituents in Goodyear's brine water. For instance, arsenic levels at a uranium mill site in Durango, Colorado were lowered by 93.1%. At another site in Monticello, Utah, selenium levels were lowered from 18.2 micrograms per liter to 0.1 micrograms per liter. It is not certain that this process will remove the contaminants or that it will even remediate the brine to regulatory levels, but our group believes that this is a viable solution that deserves further research. And I must note that this is a supplementary technique. We propose using the PRBs after the brine has passed through the wetlands.
All right, so for lessons learned, as in any sustainability dilemma, there's going to be inherent trade-offs involved, especially in Goodyear's unique setting in that it's inland. Any of our proposals will provide trade-offs between financial costs, environmental benefits or harms, as well as stakeholder agreement. So ultimately, it will be about choosing the best scenario which provides the least amount of trade-offs for Goodyear. And furthermore, our study does correlate to key competencies involved in sustainability, including, not limited to, interdisciplinary research, multi-stakeholder agreement, concepts again of uncertainty and trade-offs, and as always, the balance of ecological, social, and environmental benefits, and economic, sorry. That being said, our research is thorough, but cannot be entirely comprehensive. At the next step, we would recommend to our stakeholders that you involve experts to advise you on the specific context of the environmental and economic cost in Goodyear, as case studies can't exactly translate directly into what it might be for you. And especially with the PRB example, as the research isn't even done yet, you might want to consider hire someone to bring that in and do that for you. Lastly, in addition to brine disposal methods, we would continue to recommend that you work on preventative measures and water conservation to begin with, especially as your population grows. It's always a good idea to conserve the water in the first place. So as this wraps up our proposals, we have our references for you here, and at this point, we're happy to take questions.
Okay, so a few minutes for questions. Open it up to the class to begin. Okay, as expected, everyone's quiet today. To the city, if you have any questions that you'd like to ask. And I have a couple of, if you want to think. So one question I had, you talked about privatization, so why? Why privatization?
Oh, just for cost, basically, because the city is growing and has to worry about roads and schools and other things I touched on in the PowerPoint. So basically, just to make it more cost effective and to be able to develop education and other aspects of the city besides water treatment.
If I could add to that too, it might come in handy if anything does go wrong. The blame might not necessarily fall on your shoulders.
And I had another question about the scalability of this, the idea for agriculture. So it sounds experimental at this point?
Yeah, pretty much. I mean, that was really the only article I could find on it. So it's still relatively new. It's a growing field, but it's definitely something to look forward to or into.
Especially with that was just one picture of the algae, and they said they have to clean that up every 2 days. So that is just a constant thing they have to dispose of every other day. So we think with so much algae that it could be definitely beneficial.
Any further questions?
I have a question. How do you guys propose disposing of the leftover waste that might have toxic materials from the evaporation ponds? Did you see any methods?
No, we did not actually.
I don't think
Oh,
we're-
My question was on the algae. I didn't quite understand. You said you got growth from algae using brine wastewater. I mean, I missed that. Can you just?
It was combined. It had wastewater, brine, and then algae also growing in it. And he would use a shaker table to basically mix it up and stir it up a little bit. He was growing them in beakers,
Okay.
so he would shake it up a little bit, cause the algae to grow from there, and it was reducing the chemicals that were already found in the brine and the wastewater.
Okay. Well, I think I saw that in the sheet. You have a brine. I think you went through that. Okay. Thank you.
Let's thank this group.